So now we're going to apply our new learned mathematics in TensorFlow to the problem of estimating a regression line. So the first thing we do is define our own data so that we know again so that we perfectly know what's going on. So let's create this function, make noisy data. So I'm going to specify a slope equal to 0.1. I'm going to specify a constant equal to 0.3. And let's say we're going to generate 100 data points. So feel free to play around with this function and generate your own data. So my x variable is going to be tf random uniform. So it's going to be uniform on 0, 1. And the shape is going to be I want n of these draws from the uniform distribution. I'm going to generate noise. That's going to be equal to t random. Let's have normally distributed noise. So again, shape is equal to n, and the standard deviation is equal to 0.01. Again, this is a variable you can play around with. So y is now going to be equal to n times x plus b plus the noise. And this function returns return x and y. And now I'm going to define x train, y train equal to make noisy data. Yeah, so I have now a variable, a vector x and a vector y with my data. And we want to now reverse the process. So I have my data and I want to estimate what the best guess is for my slope and my intercept. So we're going to use TensorFlow for that. So I'm going to say m is a TensorFlow variable. And let's say we start at 0. B also a TensorFlow. Oops. Oh, TensorFlow variable, starting value 0. I'm going to define a function predict, which still depends on x. And then y is going to be equal to m times x plus b. And the function returns y. Again, note that predict is not a function of m and b, because TensorFlow already knows that m and b are variables, so I don't need to explicitly use them in the function definition. So to build up our loss function, we're going to define the squared error, which is going to depend on y predict, so the predicted y and the true y, and we're going to return tf, and then the function is going to be reduce mean tf square. So we're going to take the square of the following term, y predict minus y true. Yeah, so we have this vector of predictions of y, and we have this vector of true values of y. I take the difference, I square it, and then I take the mean of all these terms. Yeah, so I take the sum divided by the length of the vector y. So now the loss is going to be equal to squared error. I'm going to predict, so that's my function predict, so defined up here. So I'm going to have predict x train, so that's my training data. I'm going to use the function predict to generate my predictions for that training data. And of course my true y variables, these are the ones that we called y train above. So to start with, my loss is going to be, we didn't make any error, so I'm starting with a loss of 0.12. So now I'm going to again build up my minimization routine. So first we're going to have a learning rate. So let's choose it equal to 0.05. We may need a bit more steps in this case. So let's choose steps equal to 200. So there we go for I in range of steps. We're going to do the following with TF gradient tape as tape. My predictions are going to be predict xstring. Yeah, so in the function predict are hidden the variables m and b, the slope and the intercept. And as I go through this loop, for when I goes from 0 to 200, my m and b are going to be updated, and I get new predictions each time I go through the loop. So the loss is going to be squared error of predictions, and of course my true values of y, which are equal to y train. Oops. Then we're going to have gradients equal to tape dot gradient for the function loss, and I want to have the derivatives with respect to m and b. Then I'm going to update m, again using assign sub of gradients. So m is the first one. Yes, specified it here as the first one, so that's index 0 times my learning rate, which is eta. B assign sub gradient, so that's second derivative, so that's index 1 times the learning rate, eta. We may want to have some updates, so if I can be divided by 20, then print that we're at step D and at loss F, and then we're gonna define those placeholders as I and loss dot numpy. That's that one and that's that one. And then finally, the thing that we're interested in is what is the value that it found for m for the slope, and what's the value that is found for the intercept. So let's see whether we made any errors, any mistakes. No, we didn't make any mistakes. So we started off at this loss of 0.12, so we're able to bring it down to 0.0001. And then the slope is equal to 0.11. So remember the way we generated the data was a slope equal to 0.1. And the intercept is equal to 0.29, and we generated the data with an intercept of 0.3. Yeah, so that's actually not so bad in terms of what it can predict. So let's finish with plotting the results that we have just found. So let's first plot x train and y train. Yeah, so here we want to scatter plot. So we could have used PLT scatter, but you can also use PLT plot. As long as you tell it using this dot here, this dot, that you want dots and not a line, and the R means that it's going to be red dots. And the label here is data. Yeah, this is the actual data that we have, and then we have PLT plot. Again, X train, predict X train. So let's say we want this in blue. The label here is going to be a regression line. PLT, so we want a legend, and PLT show. Yeah, so this is then our final result. So the red dots are the data that we had, that we generated ourselves. And then the blue line is our regression line that minimizes the vertical distance between all these dots and that line. Yeah, so that distance is squared, all these vertical distances, and that's the thing that we've minimized in the regression.